All right, turn this off. And let me check my iPad to see if we're live. Dun, 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 dun.
What's up, guys? I just wanted to make this video as a
live day 115. Okay, we're good. Day 115. All right, guys. Today is day 1 of getting cracked at LEETCODE. We're going to be following this LEETCODE roadmap. And we're probably just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. So if you want to get 10 questions a day, we're probably going to have to cover more than just one topic a day, which is okay. I think we can do arrays, 2-pointers. But as long as we get 10 questions done, I'm happy, because the end goal is to have completed 150 questions by the end of this month. So yeah, let's just get started. I do want to preface that I've done like a couple questions in here in arrays and hashing, and a couple in 2-pointers, but I literally haven't touched anything else in here. But yeah, so the arrays and hashing, some of those might be reviewed for me, so it might be a little bit quicker, but anything past arrays and hashing, like for example, any of the trees or the sorts or searches, it might be a little bit of a, no, it would just be a lot harder for me. But yeah, so today will probably be not too difficult. I've probably looked at some of these solutions before. But yeah, let's get started. This is the first question. Let me let my friend know that I'm live. What's up, bro? I'm live. Did you want to complete the roadmap with me? All right, that's sent. Wait for his response. Well, actually, you can just watch it. Yo, bro, I'm live. Took a while to get the stream up. Check Discord. Do you want to start from the top? Oh shit. Of the LEETCODE 50. Yo, what's up, bro? Yo, what's up? Can you hear me? Yo, bro, got the stream up, bro. I got it working. It took a while to set it up because, man, I was just having so many issues with my live chat and stuff, but I got it working now, so we should be good. Do you see it? Is my stream up? Okay, perfect. Yeah, day one, I want to complete all of these. I've actually done some of these before, but only like this one. I didn't do the other ones here. So I'm going to start. Today's mostly going to be a review day, unless I just completely forgot everything here, but we'll see. Okay. So it contains duplicate. Did you already do this question? Okay. Okay, shouldn't be too hard. Given an integer array nums. Okay. Are you following? Did you do the first two here? The first. Okay, I gotta catch up then. All right, let's see. All right, I'm gonna. Given an integer array nums return true if any value occurs. Otherwise, return. Okay. Let's make a set. So for this question, I'm thinking about making a set to store all of the values in nums. So for num in nums, for each element in nums, we are going to oh shoot. Cannot type today. We are going to add the element. But we first need to check if num is in the set that we created. So if num in set, return return true, because we want to return if the value is in the set. Return. If it's not in the set, then we're just going to keep looping through. So add value. We're going to add, should be here, add value. So we're going to add nums to the set. If it's not in the set, and check, oh my god, check if the value, if num is in the set. And if there's no duplicates, we can return false. All right, let's go over the code again. So we're going to make a set to store all of the values in the array nums, and we're going to loop through the array and check for each num in nums, for each element in nums. If it's in the set that we're creating, then we can return true, because that means there's a duplicate. And if not, we're just going to add that number to the set and continue looping through. So this should work. First, let's run it real quick. Oh, I need to log into, okay. I gotta log in real quick. Google, oh, okay. Mm-hmm. Okay. Can I do both of that? Oh, okay. Let me know when you can see it. I think I did it. Okay, my computer isn't that good, so because I'm streaming. Oh, okay. Yeah, my monitor is good. I'm using a big monitor, but my laptop that's connected to my monitor is pretty slow. So I don't know if opening these. Okay. Oh, if so I messed up. That's the set name. Okay, great. That's 1 out of 10 for today. Or let's submit. Okay, perfect. Awesome. Let's go 1 out of 10. Quick review of if the thing has duplicate. On to the next. So this one and then two sum, and then we're gonna be on the same page, right? Okay, this should be pretty easy. Given two strings, return true if the two strings are anagram. What's an anagram? An anagram is going to be a string that has the same characters as another string. But the order, okay, so the order can be different, which means that we can't just, okay, so check if, we want to check if the string 1 has all of the same characters as string 2. Order doesn't matter, reverse doesn't matter. We just want to check to see if it has all the same characters. I think we can do a one line solution to this. Return true if set string 1 is equal to, oh wait, it means this exact same characters. No, we cannot use a set because there can be multiple instances of R, multiple instances of A. So we actually have to use a hash map. All right, so let's make a hash map for string 1. We're gonna call this dict1. Dict1. We're gonna use we're gonna create the hash map. So for character in S, for each character in the string, we want to add that character to the hash map. And how can we do that? Well, we can, is it character? So for each character, if character is in the hash map, so what we want to do is we're creating a frequency table with this hash map. So we're storing the value as well as how many times it appears in the string. So we have dict1 at, oh, not character 1, at character. So if it's in there already, then we can increment the value. If not, we're going to set equal to 1. Okay. So this is just making a hash map for the first string. We can make, I think the best way to approach this is to make another hash map of the second string. So we're just going to do the same thing except substitute our values. Do that. Okay, so we have two hash maps now. So let's just comment this out. Make hash map 1, make hash map 2. So we made these two hash maps, and we have the number of occurrences for each value, but we need to compare these two. So how can we do that? We could loop through, or we could just return true if dict1 is equal to dict2. So this will return true if the hash maps are equal to. This is kind of a cheeky solution that I remember. It's just a hash map operation where we can compare them in Python. But yeah, it will return true if all the keys and values are equal to each other. All right, great. Yeah, so a lot of this is like, you shouldn't feel too bad if you know, someone watching this doesn't get it on the first try. I already done these questions before, probably like a week ago. So I kind of remember them, but yeah, so don't feel bad if both are. Yeah. Yeah, no, I think I had to look at the solution for this. So there's no, if someone's watching this. You're right. I think that we can just check it directly. So okay, so we're looping through the second one, and if it's in, let me just remove this so I don't get confused. All right. Okay. If we don't need two hash maps, we can retrieve the value of the current, so we could retrieve this value. Oh, so retrieving the value in the first hash map. Maybe, so if it's inside the dictionary, we can maybe subtract 1. I'm not sure if this is right. I'm just seeing. So that value that's being stored, for example, race car. So race car will have R and 2. So if we check R2, or if we check R, and if characters R, and we're checking through that, after one iteration, it'll be R1. That'll be the key value pair. So we can say that if all the values equal to 0 at the end of this, if all the values are equal to 0, all the key values are equal to 0, then so if R is 0, this means that all instances of R have been used. So I guess So this will loop through, subtract 1 for everything. And okay, so else. So if it's not in the dictionary, we can just return false. That's a given. Or yeah, if it's not there, then that's a given. We can return false. But now we're stuck on this. So if the character in dic1 okay, so if dic1 at character so if dic1 character okay, no, we can just we can just loop through okay, so what I'm thinking is, by the end of this for loop, and if it's an anagram, then all of the values, all of the values should be, all the frequency should be 0. So we just need to loop through the values. I don't know how to loop through the values. Whatever. So if maybe we'll just do like key value pairs. Oh my god, this formatting is terrible. Okay, this is what I think. I don't know if I'm iterating across this properly, but oh my god, it's not even right. Yeah. Okay. Oh my god, I got it. Oh my god. Oh god. Here? Would this run, or would I go like this? Remove what? Oh, remove this too? Okay. now think. Yeah. Okay. Yeah, that's right. Yeah, that's right. So how can we check to see we could do if it's lower than 0, then we know that there's if it's like a negative number, we know that there's too many occurrences. So we can at least check for the negative one. We can at least do that in here. This is just one way to optimize it. I know it's not going to solve it, but what else can we do? Oh shit. Oh shit. Okay. Wait, is that it? Oh, it is it. Yeah, because if there's a that's all we have to account for if there's too many because we oh my gosh, bro, that's so big brain, that's so smart. Oh, okay. All right. Yeah, because we still have to check if it's not in there. Okay, I'm gonna submit. Oh, ooh. Okay. What the? Okay. Input XX. T. So it's returning false. There's only two ways. Oh, it's because if we're looping through the dictionary, wait, else, no. They all have to be in. I'm just gonna try. What? I don't know how that made it not run. It should be the same. Should be the same thing. From is it collection? No. No, that's right. Do you have any idea? Do you know why this is not running? Or this isn't passing? Mm. Mm-hmm. This line? Copy it. Mm-hmm. Why did that? I did this wrong. I don't think I can. Maybe I can't import anything in LeetCode or NeetCode. Okay. Okay. I was using the default dictionary, so I wasn't sure if that was. I thought in Python we had to like either initialize it with like a 0 or like a dot get 0. Okay. Which one? This one? Or this one? If character 1. Yeah. Nope. Yeah, there could be. I thought let me check. I think we might have to. Alright, let's see. We might have to check to see if it's in the hash map. And then if it's in the hash map, then I think it's a Python thing. Yeah. I I I thought that like we can't add to a null value for hash maps. So if it's so don't we have to set it to 1 or 0? Like mhm. Yeah. Yeah. Oh, I just don't know why it's what syntax error is happening. Okay. Okay. Mhm. For which one? Mhm. Okay, let me check. Oh my god, what's happening? Okay. Hmm. Oh, you checked to see if the lengths. Oh, that's you optimized by checking if the lengths are equal. So right here you did if. Oh my god. If length s did not equal length t return. Mhm. Mhm. Yeah. Do we in this? Okay. Do you think I have to check to see if it's in the dictionary? Okay. Okay, let's do the normal hash operation. I don't think so. It's still not running. Wait, this has to be. No, wait, we don't we have to. Oh, okay. No. Mm-hmm. Okay. Let me try if. Oh, thank God. Okay, I'm gonna see if. I think it's just a Python. Yeah, that's what I was thinking. Yeah. Okay. All right. Let's review it. So first, we don't even need this, but this is just an optimization, I'm pretty sure. Oh, we do need it. Okay. All right, we need it. All right. So okay, so we want to make sure the lengths are equal. Very first thing right off the bat. And then we want to make our first hash map. So we're going to loop through the string and make the frequency table. And then we just do that. And now we want to loop through the second string. First thing is we need to check to see if it's in the initial one. And if it's not, we can return false. And then, if else, then we can subtract 1 from the value. And if it ever gets below, then we can return false, and then we can return true if it finishes the loop. So what's the time complexity of this solution compared to the one I originally had? Yeah, I'm asking you. Okay. Okay. So wait, it's not S times T because you have two for loops, right? S plus T. Okay. 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 All right. I just reviewed it. All right. So I'm gonna check links, make hash map 1, create frequency table, and now for the actual logic part, loop through string S, loop through T, check if not in return false. If not in dictionary, not anagram, not a valid anagram. And since the next character is in the dictionary, decrements value of car, and if it ever goes below 0, it's not a valid anagram because too many occurrences, and we'll return false. If it finishes the loop, we can return true. All right. Question 2 down. Let's start question 3, and then after question 3, you can take a little break, and then do the rest. Little 10-minute break. All right. Next question. Okay. This is two-sum. So given an array of nums and an integer, we want to return the indices I and j such that nums at I plus nums at j is equal to target and I does not equal to j. Okay, so it says that only one valid answer exists. So when you return a specific index, I'm going to return a pair of indices. All right, so my initial approach to this is I want to create a hash map of all of nums from the hash map. Then I would just do brute force. Okay. All right. Don't even remember how to do this brute force. So for num in nums, or okay, so let's loop through nums. indices I and j. Okay, so since we need the indices, we're actually going to loop through. Actually, let's use Python function to store both the indices and the values. So if num's at I, so starting from this initial example, our target is 7. So we can start from 3. And I think we can do a kind of like 2-pointer. So we can start I at index 0, of course, and we can start j. Let's say j is our second index at 4. In our first iteration, I mean, we're gonna find that indice. So let's just account for that real quick. So oh shit, what am I doing? Okay, so if num's at I plus, okay, let's actually make a variable called current sum. This is yeah. And then, so this is going to find our current sum. If our current sum is equal to our target, then we can return, I and j. If not, we want to move we can move our j pointer, or regardless, we're gonna. Oh shit! If not, regardless, we're gonna increment j, right? So, yeah. So else we're gonna increment j, or while j is less than length of nums. Okay, so that means we can move j until it reaches the end of the list, and we could keep running that, but that will check, that will check 3, 4, 3, 5, and 3, 6. But we want to move I as well. So, oh wait, actually, if we have j here, and we have 5, we just need to move. We just need to check 5 back. You know what? Let's solve this a little differently. Let's start from the end of the array. And let's just scrap this, okay? So while I is less than j, so while until they meet in the middle, if num's at I plus num's at j is, or I shouldn't have delete that current sum, but Okay, this should work. So what am I? Not return true. Return ij, and then yeah. So your output was output. What? Okay, so this just works as normal, but this one. It's their compiler. Yeah. It says there's a valid answer though. What if my sum is greater than target? Yeah. Yeah. It says there's one valid answer for each one. Okay. If my current sum is greater than target. Oh, okay. Yes. Well, it depends if the array is sorted, right? Yeah, so wouldn't it have to be sorted? So if it's greater than, we can decrement j. So if it was like, 5, 3, 2, 1, we need to sort that to 1, 2, 3, 5. So if target was, or if current sum was, so if current sum, oh wait, yeah, that's not right. Yeah, I don't think 2 pointers is actually the right approach. Because 2 pointers would only work on sorted arrays. I don't think our input's sorted always. Yeah. Okay, so if current sums put the target, if not, oh, it's because it doesn't compare. Decrease. Yeah. Okay, let me just try to understand this. -2 plus, oh wait, no. 3, wait, 0, 1, 2, -3. What? Minus negative, wait, -3 minus, oh, plus -5 is -8. Okay. So LeetCode has negative numbers, but LeetCode doesn't. Okay, well, all right. This still isn't brute force. What's brute force? Okay. Yep. 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 And then 4 and 3, and then 4 and 5, and then, oh wait, no, then 4 and 5, and then 4 and 6. Yeah. That was my bad. Yeah. 4. So 3. Okay. So 3, 4, 3, 5, 3, 6, 4, 5, 4, 6, 5, 6. Okay. Oh, that's easy. Okay. Yeah. All right. I'm not even gonna do that. We're moving next. All right. This is number 3. Or no, okay. I'm gonna take a little break, get some water, but I'll be back in like 5 minutes. How do I pause the stream? Can I do that? You can't pause. Oh shit. Okay, you know what? I don't need a break. I'm gonna just do 10 in one sitting. I'm gonna just. Right, it's been about 1 hour. I spent a lot of time on like the questions that I wanted to just spend like 10 minutes on. But it's okay. Okay, ideally I want to get these 10 questions done by at least 12 o'clock, and it's 9 o'clock for me. So about 3 hours to do 7 questions. Or not, yeah, 7 questions. I think it's possible to do like just the optimal approach with like no fault. Yeah, me too. Yeah, that's okay. I think we can. I think it's possible. 3 hours to do 7 questions, so it's about 25 minutes or about 20 minutes question, or a little bit more than 20 minutes. Yeah, should be fine. All right, let's. You didn't do this one, right? Okay, let's do it together. All right. Given. Okay. All right. So we found the optimal solution, and pretty simple. We just initialized the dictionary, and then we looped through. 1 second. All right, so we initialize the dictionary, and we're going to go through each word in the dictionary. And then here's the sort of tricky part. We want to add all the anagrams together. So what do all of these anagrams have in common? Well, they have in common the fact that when they're sorted, they're all the same. They're all the same word. Or, for example, for act and for cat, when they're sorted, they're both ACT. So we want to store ACT into the dictionary. And how do we do that? We use this over here. So you use key equals quotation marks dot join, and then we sort the word. So this is a Python specific sorted word would give us a list. So it would give us something like you know, hat would give us something like A C T. But you know, we want to combine those together, and we use this for that. So we check if the key is not in the dictionary, and if it's not in the dictionary, then we create an empty list. And then, of course, we want to append it regardless if it's in the dictionary or not. So you do that, and then because Python dict.values will return an arbitrary instance, we can return the list instead, and allowing us to find our optimal solution. All right, so we are on our fifth question, so we're halfway there. This is where the hard part actually starts because I actually have been done or I haven't really gone over the ones after that. But yeah, Eubax, Sanjay, I found the optimal solution for this question. Okay, what did you do? Uh-huh. Mm-hmm. Okay, nice. Okay, nice. For me, I made a hash map, and okay, I see. I see two. Okay. It's hard for me to read C++ code. Yeah. Mm-hmm. Okay. Oh, okay. Okay. Yeah. For me, I looped through the array of strings, and I wanted to find the commonality between all of the words. So what I did was, um, I know that an anagram means that they have all of the same letters. So I just sorted each word in alphabetical order using the sorted function in Python. And then that sorted function in Python would give me an array of all the specific letters in the word. So I had to join it with this dot join. So it goes from an array to an actual word. And then I set that to be the key. So if the sorted word is not in the dictionary, not in the dictionary yet, I'm going to create an empty list value so I can actually append to that specific list. Um, and then I said that, all right, let's actually append the word to the key that we just made. And it will loop through the words and append the word itself and not the sorted word um, for all instances that are anagrams. And then because Python dict.values returns an sort of like arbitrary, like it doesn't give a nice list format, we have to use a list operation. So I use list. Okay, I think we are good to go next. All right, this is number 5. So 20 minutes in, so we're making good progress. If you just spend about 20 minutes for the next 5, 6, 7, 8, 9, 10. Yeah. So next 6 questions. All right. So we want to return the elements that have the most frequency. And since element 2 appears twice, okay, a set, I think you need a hash map. Yeah. Okay, so if there are 6 elements, if we have 7 of the same element, then we need to store manually maximum possible frequency of any numbers length. Yeah, let's do that. I think we can do a bucket sort thing. We'll just call it frequency. Yeah, fifth question. Did you have your system design class today? No, you do. Yeah. I was thinking about just going through the Hello interview, system design in a rush. System design in a rush. Mm-hmm. Yeah, I do. I think I want to get good in backend first. So I'm gonna start some projects soon. Yeah, so this was a pretty hard question for me when I did it the first time. Um, so I kind of just remembered what I did last time, which was make a frequency, count the frequency for the hash map. And after I made that hash map table, I want to create some buckets because I want to store, for example, in this example, if so 3 can appear a maximum of 1, 2, 3, 4, 5, 6 times. So that means you want to store frequencies from 0 to 6. So we make buckets like and then after we make these buckets, so this is what we have for frequency right now, and we want to go through that frequency table we made, and we want to put each key inside the value. So in this first bucket, that would mean that the number doesn't appear at all. The second bucket would mean that the number appears once. This number appears twice. This number would appear 3 times. So it would be the frequency. So we want to store the value of. We want to store the key to the value. So we go through the dictionary, and let's say the dictionary at 1 appears 1 time. We're going to append 1 at the first bucket. And then if dictionary if the value 2, since we counted that 2 appears 2 times, we're going to put 2 in the second bucket. And we're going to do that for 3 as well, and we'll see 3 is at the third bucket. So we're going to have a new list of something like, we'll have our, 1, 2, and then like 3 in that order. After this loop. So now we want to actually return the k most frequent elements. So we're going to loop from the end. So we're going to start from 3, and we're going to loop from 3, and then go backwards in this direction. So that's what I do in this loop. And then we could stop at 0, because 0 is just an empty bucket that we don't really need. And so for each num, so for each of these, for each array, or sorry, list, for each list in here, because for each sublist in here, there can be multiple values. So this could be 3 and 4 if 4 appeared 3 times as well. So it can store multiple values. So for that reason, we loop through. We actually loop through each of these sublists, and then we append starting from here the number, and we would append 4, and then we keep doing that until the length of this actual list. So if k was 2, right? If k was 2, then after we append 4 and then 3, we'll reach k. So we do that until we reach k, and then we return res when we reach it. So, all right, so for here, I just make the frequency table, but I loop through the entire array, so that's n, and then for here, I'm just making a new array so that it's negligible, and then looping through the hash map. And appending keys. I'm pretty sure that that's still negligible. And then we need to loop through the answer result starting from the end. So the total time complexity, I think should just be O of n. Because it's just, we're not sorting through the same, Yes. Yeah. Yeah, this is a hard question. Like this is not intuitive to me to just use a bucket sort. Yeah. But I feel like because like I did the question, like I know when I'll have to use a bucket sort again. Like I know I'll have to use a bucket sort when I need to store multiple values in in a list by frequency. So I feel like it's a good like breadth approach, but if you want to actually get good at LeetCode, like actually get good, it's probably not good to follow LeetCode 150. Oh yeah, this is like just one of those things you look at the solution for sure. I remember it. It was like this. So it was like the hash is the length of the string. So I'll tell you the hash. So you could probably just code it. So this is the hash. So length of the string plus plus the hash plus plus the string. So in Python, okay, so the question asks, so we need to convert hello world into return a string. So yeah, so so length of str would return a integer value, but we want a string value. So I think we can just do that for Python. And then we can, yeah, so this is our actual, I think you can work off this. So for example, in hello world, we're gonna encode it to be the length of the string 1, 2, 3, 4, 5. So 5 and then hash and then hello and then world is going to be 1, 2, 3, 4, 5 hash world. So this is what we're sending to the decoder. And the reason why this works is some math thing, some complicated math algorithm. But pretty much if we do this, then we'll have we can send this to the decoder and decode from there. So encoded string. Oh my God, what am I doing? Oh, jeez. And obviously, oh shoot. Obviously, what the heck? We gotta loop through everything in string. So this would be our encoded function. So given this, I think we can both work on the decode because we just gotta decode this, for example. Does that kind of make sense? Yep. Yeah, so you would loop through the string, or you're looping through this, right? So you loop through this, and we can go till we find the hash. So, we can loop through until we find the hash. And once we're at the hash, we know that the length of the string is this, right? So the length of the string is this value. So we know that we would actually, since we know that this is the length of the string, that's what we'll iterate. That's how many times we'll iterate. So first we'll start here, and then we can start here and you go till here. Then we could somehow add everything from here to here, but I don't remember the exact operation, to be honest. I wonder if I did this. Okay, so we got that. Oh shoot, can I not stream this? I don't think I'm allowed to because it's a premium. Returning in that same array. So starting, let's do a 2-pointer. I is length less than the length of S. Let's set J to I. And that's going to be the first number. So while strs at, so we're going to look for the hash. So let's look for the hash. A little bit roundabout way. And you can increment j until we find the hash. And then yeah, so if if it was like 20 or something, we would need to the length of our string would have to be from the string from I to j, and we want to make an integer value of that, so we can add it to our array, and then so right now j is pointing to the hash. So the actual start would be j plus 1, that would be the first letter, and then the end would be the index of the end would be from start to length. Right? Is that right? No. Oh yeah. Wait. Yeah, because it'll be the length of the string. So if the length was 5, we're going to start at, index 2, for example, and then add 5. So till index 7. So from 5 hello world, so it was H, add 5, 1, 2, 3, 4, 5. Wait. So we'll end on the number, I think so. And then, our, word or we'll call it stringly, is going to be the string from the start to the end, because we know n doesn't get the 5. It'll start at 5, or start at h, and then we can append that. Jeez, this is so hard. Okay, and then I think we can just return the code. Oh my god. STRS. Oh my god. Return encoded string. STRS is not defined. What? Oh, this is S. Infinite loop. All right. Oh, we need to move our I pointer. So our I is going to go to the end. Okay, this should work. Okay, it's not working. Invalid literal. What? Line 15. Line equals int. Yeah. Or, yeah, string to integer. I thought you could just do int. Do I have to import something? I don't know. I just had to ask GPT. Not waste too much time. It's already 10. All right, let's see what GPT says. Oh. Okay. Oh my god. Okay. Yeah, that was pretty dumb. I just messed up my original encoding. Okay. So pretty much I'm gonna loop through the string, add, you know, for every word in the string, we want to add no, what? Okay, loop through the list, and for each string in the list, we're gonna add to encoded string the length, the hash function, and the string. And we're gonna send that to your decoder, initialize an empty array, and we're gonna do 2 pointers. So while I is less than the length, we can set j to I, and then while the j pointer is not equal to the hash function, we can increment j. And the j is going to stop at the hash function. So our length is going to be that distance from, or it's going to be that string from I to j. Let's say I was let's say I to j was 3 elements, and it was like 365 letters in the string. That's why we got a loop from I to j. And then our start is just going to be j plus 1, and our end is just going to be the start plus the length, because we want to loop until the end. So that's going to be our end. And then that the string is going to be the start to the end. We can loop from that, or we could just do a for loop and do it that way. Or no, actually, no, this would be better. And then we want to append stringly that specific string to the array. So we'll have those words appended, and then want to move our starter I to the end, and then our j is going to be set to I again, and it's going to loop again. I think this has our decode function is a event operation, or maybe I times j, maybe, or no, we're just, I think it's just L of n. We iterate through every string in the list. Okay, encode is L of n. Decode is a while loop, iterating through the string one time. Yeah, so we while blah 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 blah, and yeah, it just goes from beginning to end. Yeah, both are L of n operations. Okay. Okay. How'd you feel about that question? Yeah. Yeah. That's a difficult one. All right, let's actually take a break this time. Damn, we're only halfway there, so okay, an hour and a half for 5. That might be a little unrealistic. Um, but let's at least, try to finish the first. Um, okay, we are, only 3 left here. That, this is this is easy. We got this. We can do these 3, and then we can do a LEETCODE. Okay, yeah, we can do 10. We can do valid palindrome. Okay. All right. Okay. I'm just gonna do these 3 and then 1 2-pointers question. So I'm just gonna go in order. Where is that? Oh. Oh, you're looking at the not the roadmap. You're looking at just this, or just this. Yeah. I'm just gonna do these. Okay, I'm gonna take a quick break. So I'll be back at 10 by 10:30. Okay, so 9 minutes. See ya. Stream. We are back. There we go. We got some food. We got some mashed potatoes and green bean. What's up, my bro? I got some food. I was hungry. What is your favorite food? Chicken? What's your favorite dish? Anything? Wait, are you from North India or South India? Northeast India? What is the popular food there? Paneer? Bro, I love Indian food. I've had butter chicken. I've had naan. I've had roti. I've had samosas. Yeah, I love egg samosas. Those are good. Oh. I've had gulab jamun before. It's like the sweet balls, right? Do you like paneer? Yeah. Oh yeah. But like the sauce has enough like flavor, right? I'm I'm not vegetarian. Yeah, I could never. Maybe there's a lot of Indian restaurants here. It's just you gotta. I just haven't been to many. Yeah, yeah. Yeah. There's probably a lot that I don't know. That's nice. Is it spicy? I like spicy. Oh, I've had goat before. I've had mutton biryani before. Oh, here? Oh, wow. Dang. I don't think so. That looks so hard to cook. I'll need a pot. Yeah. Have you made it? Or your parent, your mom? Yeah. Yeah, I do the same thing. This looks so hard to cook. Dang. This guy's been looking for a compiler role for 138 days. That's almost 5 months. Or that's 4 months. Almost 4 months. Yeah. Yeah. Oh yeah, there's a lot. Have you seen this video? It's so cool. Wait, let me change my stream so you can hear sound. I think it's oh, it's going there. Yeah. Yeah. He used like a bioluminescent. Yeah, so he used this is real water. It's a natural occurrence called bioluminescence. So there's actual like bacteria that make it glow in California, and it looks like this. Yeah, this is real. Yeah, so in this water, there's the bacteria and the organisms that live in it. He put it in this like chassis, like this little container. Yeah, so whenever there's oxygen released, it causes the organisms to move, um, and it shows this. Yeah, it's crazy. um, this is real. See these little like pipes? Yeah, it's crazy. Day 42 of vibe coding 8 hours a day until I'm a billionaire. Damn, this is crazy. This one? Oh. Mm-hmm. Yeah, this is good. I need to practice the time and space complexity because I'm not really great with that. Yeah. How many videos does it still have? Mm-hmm. Dang. We are going to be solid hires. We are going to be solid hires. We, yes, me and everyone in the stream. All right, I'm ready for the next one. Your keyboard. Oh. We can make a prefix and suffix list, but we can also just multiply the suffix directly. Okay, so for this question, we're given an array nums, and we want to return an output where output at I is a product of all the elements of nums except nums at I. So let's just start with making one prefix list and one suffix list. So how can we do that? Well, if we're multiplying 1, 2, 4, 6, so we have 1, 2, 4, 6. Our final result is going to be 2 times 4, so 8, times 6, that's going to be 48. Oh, it's right here. 48, 24, 12, and 8. So how can we go from that to that? We know that when it says it's a product of all the elements of nums except nums at I, that's pretty much the left element times the right element. So we can make an initial list of, this one would be 1. This one would be 1 as well. 4 would be 2 as well. And 6 would be 8. So this would be our prefix list. And if I didn't explain it well enough, it's because I'm basically trying to say that this is left. Each element is left product plus right product. Prefix and postfix. So yeah, so we do that 4 times. So it's not just for this. So bam, bam, and bam. Okay. So if we do that 4 times, right? So this is the left product. So that's the prefix list. And the right product is going to be, everything on the right side. So what's on the right side of 1? That's going to be 8. So that's 48. What's on the left side of 2? That's just going to be 24. What's going to be on the right side of 4? Just 6. And obviously, there's nothing on the right side of 6, so we can just do a default of 1. So how can we get these values, right? So we just defined this as our prefix and suffix or postfix. So we know that given this integer array nums, how can we make these lists? So prefix equals 1, we'll say prefix list is equals that, and then we can loop through our array, and we can add prefix underscore list dot append, let's actually calculate it. So prefix equals so how can we append 1? So we okay, let's just think about it like this. Nums at I plus 1. So we want to actually iterate through, since we need the indices. Okay, so we have that. We have our prefix. So we want to multiply a current value to nums at I plus 1. Why did I do this? I don't even know why I did that. Okay. Yeah, so this should give us that first list. No, this is right. Okay. So that should give us our prefix. And now let's do our postfix. And let's make our postfix list. I know we can make this more efficient by doing it probably like within this for loop that I'm about to make, but I just want to make the postfix list first. So for I in, the same length of nums, and we want to use, postfix once again. Oh, actually, we want to start negative, right? So we're just going to start from the end. All right, starting from the end, we're going to do postfix is going to be okay, there we go. So we have our two lists, right? And now we want to, get these lists, and so our answer is going to be postfix at I. So while I is less than length of nums, answer is going to be postfix at I times postfix, or sorry, not answer, product of I guess final product. Final product is going to be postfix at I times prefix at I and then we're going to append final product. All right, this is what makes sense to me. Let's run it and see if this works. What's unindent does not match. Let's Okay, let's just do a loop. Oh, it's gonna do an increment. Okay. Yeah, that makes sense. Let's just do I plus plus or I. What's this one? Oh, okay. Oh, okay. Lots of errors. Oh my god. Oh, wait. Oh, because okay, so we need to multiply actually by nums at I, and then yeah. Yeah. So I think this is right. This is right. Yeah. Yeah. I'm just trying to get this to work though. Why does it keep saying this? What? Yeah. Yeah. Mm-hmm. Oh. Yeah. Yeah, but what? What? Why does it look so weird? Oh my god. I don't even know what is wrong. Oh. Alright. Oh, bruh. Oh my god. Oh, bruh. Yeah. Yeah, I can do it. This should be pretty straightforward. Okay, so I'll remove this last loop. I'll remove this. And I can move. Let's move. There's two. And I think we can keep this, but we don't want to make the list. Or let's make the list. Okay, so instead of appending, let's initialize it with n length n length. Oh shoot, the length of nums, and that will give us our empty array. Oh shoot. Of 1 1 1 1 1. Where? Okay. I'm gonna loop through this, and you want to set answer at I. Prefix to prefix, and then multiply. So same thing. We can keep that, and then yeah, that's right. Okay. And then we can do the same thing for postfix. We can remove this list, and instead we can. Oh, we might have to change this a little bit because it's reverse. So since we're starting from the end, we want to get answer at I and multiply by the postfix, and that should be it. Okay. Oof. The hell? Oh, should be I. Okay. Okay. Good, good. Great. That wasn't too bad. So this is, I think, the optimal approach. What we're doing is we're just going to initialize the array with, n values, and then we're going to do our prefix theme. Insert I equals prefix, and then multiply by num set I, and then we're going to do the same thing one more time. Multiply by num set I. Almost every single time, this prefix list is going to have 1, and then the first element on the prefix is going to be 1 every single time, and the second element is going to be 1 times num set I. So in this case, it's 1, 1, 2, 8. And then we can just perform the operation in place. So this is actually a O of n operation, specifically O of 2n. We're looping forwards, and then we're gonna be looping backwards. In terms of space complexity, we're just initializing the array, so it's gonna be the length of nums, and then I don't actually know any. I don't. How do I? Do you know the space complexity for this? So yes. So the worst would be order. Okay. All right. Let's do the next question. That is question 5 or 6 of today. That might be question 6. Let me check. Okay. Wow. Yeah. This is a hard question. It's okay. I just gotta believe that I can do it, and then I'll be able to do it. It's valid. Each row must contain the digits 1 through 9 without duplicates. Each column must contain the digits 1 through 9 without duplicates. And each Sudoku. Okay, so my intuition is that I can do 2 for loops. So I'll do 4 rows in board. For rows in board, and for columns in board. We can set the value is going to be board at rows and columns. I just did this question already. Like, I haven't went over like anything else besides so I finished this completely like last week. I finished this completely, and I started this and tried to do this, but I haven't done stacks. So I haven't done I've done one sliding window. I think I've done this. But I haven't done trees. I don't even know what like a tree is. But yeah, I just done this question, so I think I like remember the approach. Value is equal to okay. So we know that the value is going to be that. And now we want to check if the value exists. I think we needed a dictionary. Okay, we needed to store. Okay, I remember we needed to check if value in this loop, we needed to check if value was okay. So if value is in the row or the column, okay, it was like a try condition. It was if value is in row or value is in column, or if or value is in the grid. I guess we'll just call it grid for now. Okay. So we're calling our value. So we know what our value is. So for example, at 1, the board is going to be row and then columns. And then if the value I think we can make a set for rows and columns. So because it can only appear one time. So let's import the easy default dict. So yeah, let's do that. Let's call our row set and initialize it like that. And let's do our column set and initialize it like that. And now let's do our grid set and initialize it like that. Okay. All right, so we have our sets initialized, so we can check our actual sets, and now we actually need to add. So value dot add this if statement has to be inside here. But I guess we would check it before. And then if it's, you want to return false if it's inside here. If not, we want to append it. So we can do value, or sorry, row underscore set dot add value, column underscore set dot add value, and grid this is not right, but because we need to check how to put it in. Okay, I remember. So grid set value is going to be equal to the row mod 3, column mod 3. And the reason is because if you look at the Sudoku board, right, and the indexes are 0, 1, 2 here, and then 0, 1, 2 here, everything that's modded 3 is going to be equal to 0, giving this grid its own unique index or own unique coordinates of 0, 0. This one would be, if you're going column row by column, this would be 1, 0, which I don't know if we are, but it doesn't really matter. So in this case, we're going row column. So 1, 0, 2, 0. This is going to be 0, 2, 0, 3. This is going to be 1, 1. So we can store these values as its own unique grid. So this is the grid set. We want to store this. How can we store? How can we? All right, let's. How can we add to? How can we add to this grid set? Wait, for what line? Yeah. Multiply? Here. Oh my god. Oh, I need to add this. I thought I did it here. Oh, I can just do this. Oh, also, if the value is equal to an empty, we're just gonna skip first, just continue. Then if value is in row sets, if value is in row set, row what? Oh. Oh. Oh, we need to check the specific row. No, that's okay. Value. Oh yeah, because it's a hash map. Wait, I forgot I initialized the dictionary. So this should be this, and this should be this, and then this is, I think, just fine as it is. Because is it fine? Yeah, so it'd be grid set row right? I think we can just delete this. And then I also need to add here rows, and then here columns, and then here. This is just like syntax stuff. It's no. I mean, I could assign a variable to this. I think this. Does that make sense? If Okay, let's see. Does this make sense? So rows, columns, values, the board, and rows and columns, and then if values is nothing, then we're gonna skip it. Why is this not highlighted? Do you know why this? Okay, whatever. Should it be highlighted? I feel like it should be. Okay. Yeah, that's an odd thing. Why isn't that pink? I don't think so. Oh. No, I don't know actually. Maybe it's just an indentation thing. Let me try again. 1, 2. Wait, 1, 2, 1, 2. Bruh. Bro, underscore set. Oh, it's just a row. Or just row and just okay. Rate limit exceeded. Oh, that's a. Wait, I think this is a. Just a compiler, right? Yeah, I think this is just a compiler issue. Like okay. Wait, I mean this. I think it's like yeah. I don't think it's right because this if is not highlighted. So what? That's a good question. Okay. I did this question on LeetCode already. Oh, is this a premium or not? Okay, because I think if I share a premium, it's not like allowed because it's paid content. Okay. No. Yeah, accepted. It was pretty inefficient. Yeah. Oh yeah, I have premium. I forgot. The whole one. Oh, because we. Yeah. Yeah, I got it. Yeah. Damn. Is there a way we don't use the dictionary? Oh. Oh, that's a. Okay, I'll do it after we finish the 10 questions on the LeetCode. Yeah. Yeah. Okay, let me just review this one more time. Initialize our dictionaries. We want to loop through rows, so you can loop through range, loop through columns. Our value is going to be, the board at that row and at that column. And now, if it has an empty value, we're just going to skip it. And if the value is in the row set at row, a specific row, or the value is in columns. In the columns, we can, or if it's in the grid set at rows divided by 3 and columns divided by 3, you can return false. Row, and then we can add the value at to that row, and add it to that column, and then we can add it to that specific coordinate as well. Okay, this isn't that bad. To be honest, this question isn't that bad. Once you know this part, once you're I think that like once you know this trick, it isn't terrible for the unique row divided by 3 more. Huh. Okay. All right. So we will come back to all of these in 3 days. So we're gonna review these. We're gonna review and do questions pretty much every day, I guess. So yeah, so we'll come back to these. Hopefully they'll be even easier the next time. We got piece of cake. Okay. All right, let's okay. I'm definitely gonna have to review the one before this. Not this one. Oh, I'm definitely gonna have to review this one later. This part is this part for me was a little confusing. Yeah, me too. Okay, let's do 2 more questions, and then we can hit our goal. Largest consecutive sequence, and let's do the easy first because I don't want to work too hard. This should be really light. Oh, I already did this. Okay, well, I don't remember, so I'm just gonna refresh. Okay. Given S, return true if it's a palindrome, otherwise return false. Palindrome is a string that reads the same forward and backwards. It's also case insensitive and ignores all non-alphanumeric numbers. Okay, yeah, I remember what I did. So what did I do? 2 pointers, right? So I started I at 0, start J at length, length S minus 1, while I is less than J. If S at I or S at J Okay, let's just do this. Oh, I remember. Okay, so if S at I is not if S at I dot is L none not true, right? Return where I plus 1. If S J, so I just use this is alphanumeric function in Python, but I'm pretty sure you can also just hard code A B C D E F G H I J K L M N O P Q R S T U V W and check to see if it's in the string. So you could hard code a string like that, but if not, we're just gonna make pointers. I don't even know if this is the right syntax. Okay, and while I is less than j, and while I is less than j, I'm using this Python function. I would probably just do like alphanumeric and do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z, and just see if it's inside the string. I know you could do like some ASCII shit, but that's just like too much for me right now. What line? You just send it to me? Oh, and numbers? Okay. Yeah, I will. It's a cracked function. Yeah. Okay. I knew this was looking off. Well, okay, we'll just say as non-alpha. Yeah. What is the? I don't know the right structure for it. Maybe while not. Okay. I'll try this, and if not, I'll just do the hard code. What? What? Oh. Wait. What? Oh. Yeah. Was it? Okay. No, we skipped the question marks. So. Oh, you're right. How do I check for uh uppercase only? Oh yeah. So I think I just did this. Oh my god. Okay, never mind. Maybe this will work. Yeah, it doesn't. It returns a boolean. Character. Oh, CH equals. Okay. Yeah. Mm-hmm. 65 minus 97 plus CH or CH minus 66. I don't know. I can't do that in my head. Okay, 66 minus, okay, 1 plus 97, 20, or 98. Yeah. Yeah, 98, yeah. Okay, I get it, yeah. Wait, it says 97, 65, 97, 65. Shoot, what about 6, what about 6? Oh God, I'm so brain rotted. All right. Yeah, I get it though. This is very helpful. Yeah, thank you. Okay, so yeah, just remember 65, 97. Yeah. Okay, I'm gonna try it with that after I get this to work real quick. What is wrong with this? Well, no, this should work. Yeah, but nope. I'm pretty sure this is like exactly what I did when I where is it? Okay. I don't know what a power function is. Oh. How many rounds? Sorry, you go ahead. Oh. I feel like that might be like a specific algorithm, right? That people that like they're trying to get you to use. Okay. let's try your method then. Oh wait. If character is equal to character minus, I can just do this. Oh my, wait, I just saw what I got wrong. Wait, hold on. Let me try. I was incrementing. Okay. Okay, let me just try this. What the heck? I mean, it's still wrong. Oh my god. I used this in LeetCode though, and it was working. Let me see. Oh, you see, like like this is what I had like submitted on LeetCode. It's the same exact thing, but I guess it is not. Oh, something's different in here. What is different? Wait, let me see if I can find. No, but something is causing it to change. So like here to here, can you spot the difference? No, but one's passing and one's not. Okay. Oh, there's literally no difference. Oh my god. It's gonna be like something super dumb. Like it's gonna be something super. Oh my god. Here, bruh. Ugh. Bruh. That was like such a waste of time. Yeah. I think the Python function on Discord. What are you trying to send? Is it too big? I think our brain is cooked from so many questions. So we can't think very well. But we only have one more question left, so that's good. Yes. I mean, it was mostly review, so it's kind of sad that it took me 4 hours to review. But it's okay. Progress is progress. We'll take it. We got this. We got this. Oh wait, I'm gonna get a drink real quick. I'm thirsty. Oh, I had it muted. I had it muted for and you. Okay, wait. I have here. Really? Wait. Wait. Oh. Okay. Well, I don't know. Let's just get this last question, anyways. Just one more question. All right. Yeah, we'll worry about it later. All right. So I'm gonna try to go over 2-pointers and stacks, the patterns tomorrow. So tomorrow morning. So tomorrow night we can just drill 2-pointers and stacks because that's 10 questions. So I'll try to go over the theory and the information about 10th question. Okay, I need to learn it though. Okay, so I'll just learn 2-pointers and stacks theory, and then at 6:30 we can drill. Okay, because yeah, I don't want to do these questions and not know how to do any of them. Okay, so this is 4 questions and this is 6 questions, so that's perfect for tomorrow. Tomorrow I don't have school. I forgot, so I can actually have time to do theory. Okay, yeah, because it's Saturday. Okay, good. Because when I have school, yeah, no school on Saturday or Sunday. Oh, really? Is that not a rule in India? Is oh really? Oh my god. Yeah, that's crazy. I need at least 2 days. So used to it. All right, last question. All right. Yes, this is the 10th question. This is the last question of the night. It's a 4.5-hour stream. Not a super long stream, but pretty tired still. Let's get this last question over with. All right, longest consecutive sequence. Given an array of integer noms, return the length of the longest consecutive sequence of integers that can be formed. Oh. This question looks hard. Yeah, which I don't remember. Okay, well, let's try to do a sliding window. Let me see. I wrote something about sliding windows. Okay. So I wrote sliding windows have a constraint metric. So what is this constraint metric? Constraint metric is that each element is exactly 1 greater. Okay, so as the okay. It's not, I don't think it's a sliding window because it's not in order, or they don't have to be contiguous or however you say it. Oh, you're right. Oh, okay, we can't use sort. So we can't do sliding window then, right? Unless we sort. Yeah, we can. Okay. But I thought sorting is okay. Oh, All right. I guess I'll try to solve it on paper because I have no idea how to do this without just sorting it first. Okay. So we have 2, 20, 4, 10, 3, 4, and 5. If we have all of those, if we have all of those, we want to start from 2 and then I feel like this is at least n squared, but it says it has to be an O of n. Okay. All right. 2, Okay, I know where to start. No, I don't. I lied. We can start this question by, since it's consecutive, we can just sequence or no duplicates set. And just make a set of norms, because that has nothing to do with consecutiveness. And let's make a loop through set. Well, let's make a variable to store the longest variable. Okay, and now we want to store the length. Probably going to be some max function. I literally did this question like 3 days ago. I just forgot it. It was like, I don't know. I'm just a teenage dirtbag, baby. Oh, nums. If nums at I is equal to nums at I minus 1, that means there's a duplicate. That's good one. And then if nums is equal to nums at okay, minus 1. Yeah. So if it's not in the set, then it's the first element. So that means it's the beginning of the sequence. So we want to check if, so right now it has, no length. So we want to check how many consecutive numbers exist. So while I don't know why I used I. This keeps tripping me out. I'm just gonna use num. Okay. While num plus the length is in no duplicate set, the length is going to be plus equals to 1. And then our longest thing is just going to be max longest. It's just going to be the longest length. And is that it? Turn. I did this like 3 days ago. That's the only way I would have like made this. This is so cracked. Yeah, this is cracked. Okay, so just a quick summary. For longest consecutive sequence, you want to find the length of the longest consecutive sequence of elements that can be formed. For me, the first thing I wanted to do to optimize it was to make a set, because for the sequence to be consecutive, we only really need one value. So we can just make a set of nums, and then let's loop through that set, right? So the first thing we want to check is to see if that element is a first element in, and the way to do that is we check one digit below. If there's no number 1 digit below, that means it's the first element. So if 1 digit below isn't in the set, we can now start counting. Our length is going to be equal to 0. We're going to initialize our length. And while our number plus the length is in no duplicate set, so while we're going to start counting our consecutives right now, so we're going to loop towards while we have consecutives. While we have consecutives, we're going to increase our length by 1. So we're going to keep running that until so that while loop is going to run until the end of the sequence for that particular for number, and I'll run only once through the set, so it'll be O of n. Actually, it'll be O of n. O of n times complexity because they're just iterating one time, and space complexity is just O of n as well, because we're just initializing. We're just going through. You should aim for a solution as good a pair than O of n time and O of n space, where n is the size of the input array. This is O of n, or a little bit quicker than O of n, right? Because we're not going through the whole nums because we make it a set, right? Worst case. Okay, note taken. What about the amortized? Because sometimes we reference the amortized. Dynamic array isn't really like a. Yeah. Okay. It's okay. I think it's also like, um I understood. It's, just getting late for me, so I'm a little tired. Yeah. So it's not sticking as well as it should. Usually, my day when I have school looks like I go to school, in the morning, and then I work, um, almost every day. So I go to school, and then I go to work, and then I might go back to school, and then I'll come home and I'll eat around 5, 6. If I have time, I'll go to the gym, and then if I don't have time, I'll just do the homework. Yeah. Yeah. Alright. Well, tomorrow 6:30? Okay, we might tomorrow goal is to do the stacks and the Qs and the LeetCode 150. So, um I think it's stacks and queues. Oh, it's with priority queue. Oh, I don't know. Maybe it's here. Hmm. Okay. I mean, we got 140 questions left here. Uh, oh. Okay. We can. Okay. Yeah, yeah. I'll try tomorrow before 6. Um, yeah. Okay. Okay. I'll go over that tomorrow. And then oh wait, tomorrow is Friday. I thought it was Saturday. Okay, I do have school tomorrow. Yeah, okay, I got confused because it was midnight already. All right. Okay. Tomorrow 6:30. I'll see you then. All right. Good work today. Good work today. Good night. End stream.